Okay. I guess I need to
Share your screen.
show myself and share my screen. Okay. Let me find the one I want to share. Okay, that one. Okay.
Gotcha.
All right, you guys ready?
Yep.
If you have any questions at any time, you can stop up. I'm at the beginning, just a second. There we go. You can stop and throw in a question anytime you want. And if I can't answer it, some of these other guys can. So this is week 5, and we're going to talk about the hard goods. We're going to talk about radios and station equipment and stuff such as that. My name is Bill Lockett. I'm AE5F. I'm an extra. I've been in ham radio for a long time. I don't remember. Mark made me take the test, so it's Mark's fault. Okay. That was in the late 80s, early 20s. Or early 90s. I can't remember. Anyway, this is this module. We'll talk about transmitters, receivers, and transceivers. And how many of you have set up your station so far, or bought a radio? Have any of you? Well, good. This is a good place. This is a good time and place to ask questions. Okay, the generalized transceiver, and we all know what a transceiver is. It means it transmits and receives in the same box, and we call them transceivers. Okay? So the generalized categories on transceivers are mobiles, which is the kind you put in your car and travel around with you. They're usually single or double or more bands. And they're usually VHF, and if they're double banded, they're VHF, UHF, or VHF and 1.25 meters, 1.25 meters. And they're usually FM. Okay, the single band ones are either UHF or VHF, FM. Dual bands are, like I said, VHF or UHF, FM. And then an all band, a lot of the newer radios for the cars they're fairly expensive, but they're all band. They're VHF, they're UHF, and then they're HF, and all the bands that are included in HF. Now, we'll talk about that at the bottom here, as soon as I get to the bottom. And then there are multi-mode transceivers. And multi-mode transceivers are VHF, UHF, they're CW, they're not only FM, but they're CW, sideband, FM, and some are even AM. Okay, and then there are the handhelds, the HTs, the kind that is generally everybody's first radio because it's the most inexpensive to get in the market with. And what I have here, if you look at your screen, is the Bofang. It's a UVR 5, and it's the one that you will get if you join SCARS. We give this one to you. Now I have added an extra antenna to it, a longer antenna. It comes with a shortened antenna. Anyway, it comes with a much shorter antenna. Like this. And you can see the difference. Where on this one, it's approximately 19 inches long. And this is about, 7 inches or so. So you have more more chance of making contact with a longer antenna and more chance of receiving with the longer antenna. Okay, let me peek at the next slide here. Okay, we're gonna talk at them by themselves. We'll come back. Oh, another option for your HT when you join the club. This one is a radiodity, and this one costs a lot more than the UV5. So you have to spend, I don't know, Mark can tell you, but it's about $40 to $50 additional to get this one. This is a pretty good mobile. With the help of the repeater, I used this one today to, I had an appointment in Noble, and I was in Noble, and I got in on the tail end of our net, and I was able to check in with this one with a good signal report, 5.9 signal report, full quieting, and I was in my car when I did it. They say it can't be done, but it can be. Okay, the single band mobile. Single band is 2 meter and a good starter radio. It operates from 13.8 volts DC and requires an external power supply or a car battery. Okay, now the 13.8 volts is what a car battery gets from the generator as you're running down the road. If you stop and kill the switch on the car, you'll get more like 12 volts. But when you're running and charging the battery, you'll get 13.8 volts, plus or minus a few tenths. But all of our radios, from handy talkies to mobiles to your station radios, are all geared to operate off 13.8 volts. Of course, they can take a little bit more, and you can run down on the voltage a little bit with the sacrifice of power, of output power. Okay, all the mobile radio requires people nowadays, or maybe unless you're a real radio enthusiast, don't like to cut holes in your cars. So they have mag mounts. This mag mount here, you can see the curlicue in the middle and the magnetic stand, and it fits down on a metal surface on the roof of your car, and it is a dual band antenna. This little curlicue in the middle of the antenna stops the radiation from continuing on. That stops a high frequency. So if you have a dual band like 2 meters and a 440, the 2 meter frequency, which is 147 megahertz, will pass this inductor and go right on up and use the full length of the antenna. The 440 megahertz will go up to this inductor, this coil, and it will stop, pretty much shut off the 440, and therefore you're only using this much of the antenna. So that antenna can work but for both 2 meters and 440. Okay, these also can be operated as mobile and base. You can keep them in your car, or you can take them out of your car and use them in emergency situations, use them as your base station radio or whatever. They can be hooked into a regular power supply that you might have at your base station. They're limited to frequency modulation FM, and are usually 2 meters or 70 centimeters, which I talked about. And they have approximately 50 watts output. They usually don't put, they put somewhat less on 70 centimeters, usually like 25 watts, if they have a 50 watt 2 meter. Some of them you can get from 25 watts. Some mobiles have a maximum output of 25 watts. But if you're in town, that's plenty of wattage to go to talk to whomever you want to. Now, dual band mobile, and dual band is what I have here. Sorry about this, but I don't have an accessory camera. So you'll have to look at it this way. This gives you an idea of the size of it. It's small and fairly lightweight. Some of them are a lot smaller and a lot lighter weight than this one. This is a fairly old radio, but it is dual band. It'll work 2 meters and 440. Plus, one thing I wanted to show you, it has 2 outputs on the antenna, 2 antenna leads. So you can either use 2 antennas or put what they call a duplexer, which is backwards, which is this, and run your 2 antennas to that, and then run that single antenna out to your tri-band, single wire out to the tri-band antenna. And that prevents you from having to run 2 wires and have 2 different antennas. You can also get these in 6 meter or 1.25 gigahertz or whatever. Okay, you might have separate antenna connection for each band, and to do that, you'll need a triplexer or duplexer. They do make triplexers. Now, a multi-mode transceiver. Now, all HF rigs are multi-mode. And HF is your what we call our station radio. And an HF rig works from 12 meters on up to a bunch of meters. We have some people in the club that are doing 630 meters, but generally we operate on 15 or 10, 15, 20, 40, and 80 are generally what we work on. Now, some people who are more hardcore work on the 30, which is digital only. So you have to know your Morse code or run digital modes on that. Or 12 and 17, which are called the work bands because they were instituted after World War II. Okay, VHF multimode is FM plus AM, and CW SSB mode, single sideband. Now, but it would only run on VHF. So it doesn't have all the other bands to work on. So you would use those bands for weak signal VHF. Most weak signals, most in-town talking and informal talking on these rigs are vertically polarized and use an antenna like this, like I showed you, this married battery. The weak signal antennas like this one. As you can see, it has lots of elements on it. A lot of, as you learned, these are the directors. This is the driven element, and this is the reflecting element. And so this is the longest element. This is the next longest, and this one is shorter than this. And all these directors are the same length as this one. They're all the same. And this has what you may ask, what is this right here? This is a gamma match, a method of making this antenna 50 ohms so that it can connect to a 50 ohm coax, and you can use it. Or in some cases, hurting your antenna. Now, we built in class, Mark told you about his tape measure antenna kit. And you can also use this for VHS or UHF, with this connection. And this has a hairpin device on it that reduces the impedance to 50 ohms, what we need. But this is to make the 50 ohms. This is the driven element. And I think Ken showed you a picture of these yesterday, but Mark wanted me to, or last week, but Mark wanted me to show them to you and show how you can, maybe, you can tuck them all inside and unfold it like this. Anyway, you get the idea, but you can unfold it. And you might want to fold it up when you're using it on VHS or UHF. But this is a good 2-meter antenna. You can put it in your attic and point it toward the repeater, and it has very good gain. And you'll very cheap to build. Okay. Of course, as you would imagine, the more features and the more complex a radio is, the more it costs. And the mobile radios nowadays have removable face plates. So as you can imagine, in today's car, they have a lot more electronics in the car. Space inside is at a premium. In fact, space everywhere on the car is at a premium. So it's hard to mount radios inside the car a lot of times. So they have the face that you can detach and put up, mounted near the back dashboard or down on the console where you can see it easily and operate it. And then put the bulk of the radio either in the trunk or under the front seat or something like that. Okay. Next, multiband transceivers. multiband, most transceivers operate in the HF bands, which I described before as being 10 through 160 typically. But these multiband transceivers will add the high frequency, the UHF and the VHF to them. And that way they cover all the modes from VHF and UHF to HF. They're a little bigger, a little heavier. This is a multi-mode transceiver. As you can see, and you notice on the back,
Oh, that's a big one.
this thing's pretty heavy too. On the back, I can show you, they have 1, 2, 3, or 1 and 2 antenna receptacles. One is for the all the HF bands, and the other one is for the VHF and UHF band. And then this goes to these two, belong to the automatic tuner that is on the side of this transceiver. Now, real estate on the front, and you lose a lot of buttons. Okay, back to multiple. Usually they're 100 watts on HF and power limitations on the higher band, to 25 or 50 watts, depending on the radio. And large units have external power supplies, and smaller units need internal power supply. I have a radio that does have a couple of radios that have internal power supply. It takes 3 men and a boy to carry those ones. So they don't make good field radio. Okay, let's get back to the AT transceivers now. They're small handheld FM units, as we saw. They can be single or dual band. They're limited power, usually 5 watts. Some of them will claim 8 watts or a little more, but be skeptical. There's not a lot you can do with 8 watts that you can't do with 5 watts. They include the battery pack, which is sometimes a trick to get into. This one's particularly hard since it has a belt clip right over the release. Okay, I'm gonna give up on this one for now. I'll show you another one that's much easier to get into because it doesn't have the belt clip on it. So you can buy extra battery packs for these. These are kind of the go-to radio that you would use for like the Oklahoma relay, the Memorial relay, or for a biking or parade or something like that. Or if you're on a search party, you'd want radios around for search parties, to search and clear places. And so the batteries are pretty easy to move. That one's an exception, but you can also buy battery packs for them. As you see, this battery pack has individual AA batteries in it so I can go to any store and buy 8 alkalines and put in here and be good for most of the day. These happen to be rechargeable, but I don't think they recharge anymore. This was, excuse me, my very first radio. And you can see it's a 2-meter, very small. Push buttons down below, usually 1 through 9, and some for operation. So you can, when I was started ham radio, it was a big deal. Our repeaters could transfer the radio signal to a telephone line. So you could dial a telephone on your handy-talkie and make a phone call on it, which was at that time, before cell phones and all. It was really the cutting edge of technology, because you either had a bag phone or a car phone or no phone, or you had a handy-talkie. Okay. And like I say, we'll give you one like this. Maybe that slides up or slides down. One like this when you join the club. It's a Chinese-made radio. The Chinese have gotten into the ham radio business, some of them, and they have made prices particularly on ham radios, come down quite a bit. The Japanese were the biggest maker of ham radio.
So does that mean you have to pass the test before you get the radio?
I'm sorry, what?
So you have to pass the test before you can join and get the radio?
No, you can join before you pass the test and get the radio,
Great.
from what
Thank
I
you.
understand. But you cannot do anything but listen on it until you pass the test.
Fair enough. Okay. Thank you.
I don't know how they are now, but this is an older radio, but it has all the family band frequency and the multi-band frequency on there. All the stuff that you go to Walmart and buy for, $18 and get 2 handy-talkies. This has all those frequencies in there. You can use it for that. Okay. Most radios now can receive outside the ham bands. They will receive everything throughout the band, almost anything, as long as the bands are wide enough to catch them. Now, these particular radios, is one I'm talking about, have a special button, and I don't know if you can hear that or not, but that's an FM broadcast. And I usually listen to the games on it. Because the battery lifetime is unbelievable on these. It lasts a long time. Also, it has a cute little doodad. He's turned on first. If I remember how to, well, I had this working yesterday. It has kind of an emergency thing, or if you do it right, you can use it as a flashlight, and it makes a pretty handy flashlight if you're out, at field day or something at night. All of them have internal microphones. If you look at them very closely, you'll see you'll see where the speaker is up here. And somewhere along there, you'll see a small hole, like on this radio, it's right here. And that's your speaker. That's what you talk into. So these are all self-contained. You can talk and you can listen. Not at the same time, but you can talk and unkey and listen. This is the key on the side. This key right here. Now, this radio is, oh, that's where I wanted to go. Okay, is it also, it does FM, VHF, and FM UHF. It also does DMR, one of the digital bands. I'm on pair right now. And if I can hit see if I can hit the receiver from here. AE5F. And then when I release it, okay, you hear that? It came back to me. So it means that the repeater can hear me and I can hear the repeater both. And that's one of the radios that's available for extra money. Some can receive that. I've got a couple of transceivers in the drawer here that will receive the aircraft bands too. So you can sit here and listen to Max Westheimer if you want to. And it's unbelievable how busy they are. Okay, these are, as you can see, they're very portable. They're self-contained. They all come with belt clips. I don't have belt clips on all of them, but they come that way. And they're pretty easy to carry around. If you have an antenna like this, 19-inch antenna, there are special antennas you can get that are very flexible, and you can just make a coil out of them, and that keeps them a lot more portable, a lot handier to have. They all come with a rubber duck antenna, which you may want to replace, you may not. The situation will vary. And they're all battery powered. All of these, you can get some type of unit where you can power them from your car battery through the cigarette lighter. And usually it entails replacing the battery pack with a battery pack that has a cigarette lighter and a cord and a voltage supply on the inside that makes sure you're not overvolting your radio, how much you can change, how much you know. Okay, extra battery packs we talked about. AA cells are, you can't go down to any stores in Norman and buy a back for your radio, a battery for it. You just can't do it. Not even Batteries Plus will sell them. So if you get a battery pack with AA cells, it's very useful because you can go into any 7-Eleven or anywhere and get some of that. Okay, a lot of these have contacts on the back here where you can just drop them into a charger and they will charge. I have my chargers over there on the table where I would drop these in and charge it. In fact, I was just charging it up a little before tonight. And they usually charge a little faster. You can get extended telescoping antennas, longer antenna. You can make antennas for them. So you can, one I have over at my easy chair where I usually check into the net has a roll-up dipole, which is made with 300 ohm O-type television wire, antenna wire. And I made a J-pole out of it and I get in just fine. And they all have little ports. If you have fingernails, you can work them. like this right here on the side, where you can add a speaker or headphones in case you're in a situation like if you're doing the Oklahoma Marathon race. It's good to have a headphones because it's so noisy, you won't be able to hear. You'll have to hold this up to your ear all the time. And sometimes just a headphone with a speakerphone. And of course, the speakerphone has a push to talk on it somewhere where you always have to push or key them to change them from transmitter to receiver to transmitter. You can't talk and hear at the same time. And when one person's talking, nobody else on that frequency is talking except you. That's one of the drawbacks of radio. Okay, let's see what we have next here. This is this slide shows some of the positives and negatives, limitations, single band. Now, most hams, when they start this, particularly if they're a little older and a little more financially secure, buy too much radio for them. They buy a big radio and they really don't know how to use it. They don't know how to install it. They don't know how to put up the antennas and everything. So it's generally easier to start, I think, with a smaller radio like the free one. You get it at the call, or you buy them off the internet, pretty cheap. But talk to a lot of people before you buy, and then get one and use it, and you'll think, well, I don't need this capability. Oh, man. It didn't need dual band. The first dual band radio I got wasn't a dual band. It was a handy talkie on the other band, but it on the 440 band. But it was a DMR radio, and we had a DMR repeater, so I had to have a radio that was the same frequency as a repeater. A lot of these radios, the Chinese radios particularly, are hard to program by hand. There are a lot of little button pushes, and their logic isn't quite like we're used to, but you can learn to do them. I've learned to program the little Bofang easily. If I the first one, it takes a while. I have to rememorize everything, but once you understand how it works, it's easy to program. Or you can usually get a computer program, and all these radios have the option of programming by computer. You'll have what looks like a spreadsheet, and it will tell you all the positions and everything you need to know. And they'll usually plug into your microphone jack to and read and write the program in the computer. We have any questions?
Nope.
Okay. Radios cost, handheld radios, you can probably buy them for $25 to $40, up to $700 for the handhelds. So, rig vocabulary. Okay, we'll talk about some of the rig stuff. And frequency selection. Fundamental to all ham radio, or amateur radio transceivers are set by a VFO. A VFO is a variable frequency oscillator. It's continuously variable. Whereas your little handhelds, they're pretty much continuously variable, but they usually work in a channelized motion or channelized mode, where you have a particular channel for a particularly set of frequencies. But the VFO is the big knob which turns the radio on or off. Turn on and off. Transceiver. If you can see it here, this is a and the big knob, they all have a big knob up here which you turn to select the frequency. Then they have mode buttons. This one has buttons, up and down buttons, and you toggle from one to the next, and it will go from a frequency from CW, beta, single sideband, from upper sideband, lower sideband, to AM and to FM. So those are the basic frequencies you'll use on radios. Okay. Now, some of these can be set by direct pad entry. This one doesn't have the real estate, as you can see, to have a numerical pad on it. So you cannot enter frequencies digitally directly. You have to there are options when you turn the knob. That's a spacing. So it can go 1 hertz at a time, or it can go 10 hertz, or it can go 100 hertz or 1,000 hertz. You know, so you can get to your frequency pretty fast. It also has you select the band on it. You know, a band like 40 meter band is from 7 megahertz to 700 to 7,300 megahertz. So it's what did I say? 700 megahertz, from 7 megahertz to 7,300 megahertz, or 7.3 megahertz. That's what I'm trying to say. So you're not tuning just a long way off, and all these have a method of switching what band you want to be on. So you'll just need to push one button or toggle up and down for your band switching. Okay, memories. Most of these transceivers have memory in them, and most of them will store frequency, mode, filter settings. Some of them have different filters. You know, CW would have a different filter setting than a phone or talking, and some of the digital things may have, you want to take all the filtering out and everything, and they may be under numerical labels, and some of them have numerical labels. Most people I know don't use the frequencies in their HF rigs or the memories. They use the memories in their HTs and memories in the mobile, because you're actually using very few frequencies. But with a HF rig, it's usually switching from one band to the other rather than one memory to another, if that makes any sense at all.
Yeah,
Did I confuse you?
and we'll get there.
Okay, transmitter control maintains display both RX and TX. Okay, so that big round knob on the front can both you receive and you transmit. You'll transmit and receive on the number that's displayed on the frequency on the display. Controls the frequency via variable frequency oscillator. BFO. You probably need to know that. Frequency can be set with a knob or a keypad or program channel. So you either spin the knob. It's a lot bigger radio, as you can see, but not necessarily any heavier. 9 and 0. And also on the keypad on this particular radio, it has your bands. It has 6, 10, 12, 15, 17, 20, 30, 40, 60, 80, and 160. So those are the bands this radio will operate on. And this radio is one of the earlier SDR type radios. A lot of it has computer controls. So the controls on this one are a lot different than the controls on a conventional radio. And we'll talk about them in a while. Okay. Let me see, tuning rate, we talked about the tuning rate. And okay. There are usually two VFOs in a radio. An A and a B is what they're typically called. And you'll use one for most of your operation. But you can use a second one. You can plug in a different set of frequencies and push a button on your radio and jump from one on BFOA to a different frequency on BFO BFOB. Now, you won't necessarily have to. They don't necessarily have to be on the same band. It depends on the radio. So you might be listening in on 10 meters and up tuning around on 20 or something like that to find something. So the main reason they're on there is a lot of the DX contacts, and by DX I mean outside the continental United States. Many of the DX contacts will talk what they call will operate in what they call split. In other words, they will transmit on one frequency and then listen on another frequency. So if he's on let's say 1400 and he's listening at 1410, would say he was, down in frequency 10 units, down 10. You would hear him on 1410, but you'd have to turn around. You wouldn't hear him on 1410. You'd hear everybody calling him on 1410. So you turn around until you found out where he was at 1400. And of course, you wouldn't be right on 1400. That's another lesson. But you would have to find where he's talking and listen, and then call him on 1410, where he's calling you on 1400. I know that's hard to understand without a demonstration, but there are two reasons for that. One reason is for a lot of these foreign countries, anytime they place a call, they have a lot of people coming back from, particularly from the States, a lot of people from the States. and it just gets too crowded and too big of a pileup for him to be able to talk and listen at the same time. So he will talk away from where he's listening so he can listen to this group of people. And then you got to be able to listen where he's talking and talk where he's listening. That's the main, one of the reasons. Another reason is that the bands in different countries are different, and they have different sections or different parts of the band. So a person may be talking on, let's say, 80 meters. Like in Canada, I think I can only, we go down to 3.5 is the lowest frequency we can go there. They can only go to 3.8 down. Okay, so they can't go. So if we were to talk and listen to 355, they couldn't get to us. We'd have to talk above 2.8. But if we wanted to get all the extra class in the U.S., we'd want to be down on that band so he can talk on that band and then listen up to you could talk at, let's say, 3.6 and then listen at 3.8 or higher and be able to get more people that way. You'd be able to get all the Canadians and all the US people and everybody. But that's a little advanced right now. But it's one reason for having the two VFOs on there. And that works out once you get it set up, once you get the split set, when you're talking, if you're using a handheld like this one, if you're talking and you're listening and you hear somebody you want to call back, as soon as you push the button to talk to him, your radio will switch frequencies to the band to the band that they will all be, to the places they'll all be listening. And then when you release your push to talk, you'll switch back to where they're talking. Okay? So you're going one way and they're going the other. Okay, the mode selector is transmit and the AM, FM, SSB. And you remember that single side band was split into either the lower sideband or the upper sideband. One with the higher frequencies and one with the lower frequencies, or CW or data. And here it has, this shows you how dated these this slide is. It has RIDI or PSK. A lot of your transceivers now, once you switch bands, they'll switch to lower sideband or upper sideband automatically, depending on which is the proper one to use on that band. Any questions so far? Okay, you guys are either tuning out or waiting to think about this. Okay, let's talk about some controls. There's a control on your transceivers, particularly the 8 transceivers that have a microphone, and this controls how sensitive the microphone is to the surrounding, to you, to anything. So the higher the gain, the louder you will sound up to a point until you start over-modulating, and you'll sound muddy. You will really sound terrible when you talk. And when you hear somebody says, you're overmodulating, you need the quick way to change that is to move the microphone away from your mouth. Say, how's this? You know, you say that's much better. Then you were overmodulating. If you're used to having the microphone close to your mouth, then you go into your gain control settings and set it for the distance that you're normally used to setting your microphone. Also, I didn't mention this, but mobile microphones, since there's not a lot of real estate on the front of a mobile transceiver, they have the buttons on the back, which allow you to do various things like move the frequency up and down or dial in a frequency. Okay, speech compressors. Most HF rigs have a speech compressor on them. And a speech compressor, what it does is when you're modulating in single sideband, you know, it's kind of like AM modulation without one of the sidebands without the carrier, but it's amplitude modulation. When you're talking, your voice peaks at a level, at a certain level. And when you talk low or parts of your voice are then way down below that. So what a compressor does is it brings those lows in your voice up, approaching the high. And the more compression, the higher it gets. And what that does, that makes your speech, in a lot of cases, not very pleasant to listen to, but it's a method that's used often on DXing to break pileups and stuff like that. When people have a hard time hearing you, you can throw some compression in and your speech sounds louder. Not as pleasant, but louder, and it's still intelligible. Okay, so that's one of the reasons somebody could say you're over deviating. You know, if your speech or you're splattering, somebody says you're splattering because your speech compressor turned way up and you're operating, you're causing splatter outside your bandwidth, and other people can pick it up. Okay, too much rain. Okay, splatter. We talked about that. Over deviation, over modulation. Modulation mainly in the FM. You know, you modulate the frequencies, and the deviation is amplitude more or less. Okay, other controls on your transmitters. The automatic level control, or the ALC. What it does, this is for output, and it limits your speech modulation, reducing transmitter overdrive. That's in case you get excited and you talk too loud, or you're popping or something like that. It's unpleasant to hear because it'll make loud sounds in the other person's receiver. And what the ALC does is it tries to limit those to basically the same level, so that when you're talking, you have the same level of speech throughout your conversation or your platform. Another use for it is to put the ALC, if you happen to have an amplifier, put it in your amplifier, and that helps control the amplifier, because if you over deviate or over modulate, you know, an amplifier too much, you can blow a tube or something like that, make it smoke, let some of the smoke out. So that's a protectorant to keep the amplifier from overdriving itself. And also, if it's not set properly, you'll have distortion. It's possible to have speech distortion or something like that, or overdrive in your transmitter can damage your transmitter also. So ALC usually has no, that's ACL. Okay. Anyway, the last model prevents overdrive and external power amplifiers is what we talked about. That's how you can overdrive them if your ALC is not set correctly. Okay. You have hand mics, which I've showed you, and there are desk mics like this one here. And if you can see right up above my head on in my station, I have a desk mic. It's on a boom that's sitting straight up on it. It's a Hell microphone, a good microphone. It's a 781, I think. And they're also pre-amplified desk mics. I have one here. I have, but I have too much stuff around to tell you the truth. I didn't want to bounce around and find everything. But some microphones have built-in amplifiers in it. So the old chicken choker is one of the famous ones that could be amplified. And you need to watch out with those too. Maybe take the amplifier out or use it sparingly.
You want to let them know what a chicken choker is?
You got one handy, show them.
No, I don't.
Probably in one of these bags down here.
It's an Aztec D104, sometimes called a lollipop mic.
That's right. It's called a chicken choker because you grab it around the neck. It has a big lever that you squeeze to talk into. Okay, speaker mics. A lot of times they're used with handy talkies. You see the police use them on police shows a lot of times. They'll have a microphone attached to the lapel, and they'll have their radio down on their belt somewhere, and that speaker mic is right near their ear, and you'll see them turn over here, and then you also see them talk into it. They'll reach up and squeeze the pickle, as we call it, and talk into it. That microphone will both receive and transmit, or receive and work like a speaker. Okay, they're headsets with booms on them. Like this. You know, if you're doing a contest and a long contest, you might, put your headset on and put your microphone down and plug it into your radio. And you have to work some way to key the microphone. And they have little keyers that you can work with, squeeze it to your hand, or they have foot pedals you can use. But you don't have to worry about your microphone or your speakers anymore. And these are a set of old HALs, but they now they're real fancy. You can phase one side to the other side, and sometimes the sound will just pop out, and sometimes it won't. But it can really help you in receiving that low, hard to receive signal. Okay, internal mics. Well, all the handy talkies have internal mics, and the speaker cross microphone. What that means is you generally don't talk in a microphone right up here, because when you do, that puff of air will pop the microphone. But if you turn it to the side like this and talk like that, then you won't pop the microphone. Any questions? Next slide. Microphone and keys. transmitter on and off keying. Okay, we showed you can key a transmitter with a boost deck. So with a hand microphone, with a desk microphone, or with an external microphone. Another way of keying them is what they call VOX, VOX, voice operated transmission. X usually stands for transmission. That's why they say exceiver a lot of times when they mean transceiver. At a box, there are three things to say on a Vox. And what a Vox does, it's like, those old tape recorders you used to have, and you start talking and they start recording. And then when you stop talking, they'd stop. A Vox is a little more sophisticated than that. But when you start talking, if you have your Vox on, it will generally start transmitting. And then when you stop talking, it'll stop. Of course, your dog in the background barking will cause it to key and go, and your wife yelling at you to do the dishes will cause it to key and go. So beware when you have Vox on, or if you happen to be doing a project and burn yourself with a soldering iron and say a dirty word, that can just pop up and transmit. If the Vox is left. The Vox has three controls. It has a gain, a delay, and an anti-Vox. And Vox gain is you want to turn it on until it hears you, until it works, until it turns on when you're using whatever microphone you're using. And depending on what and how close you use it, you want to set it so it just turns on the microphone, okay, and stays that way. And then there's a Vox delay. The delay is you start talking and it'll wait a few microseconds or milliseconds and then turn on. And that keeps it from, if you drop a screwdriver or something like that, or if you drop something, it won't turn on. It has to be something recognizes voice. And you set that. And then the anti-Vox, I never knew what, it took me a long time to learn what an anti-Vox was. But the anti-Vox, if you think about it, if you've got something that'll transmit when it hears you, what does it do when you have a speaker on the receiver and somebody's talking loud? Does it start transmitting and then he's quiet and then comes back on and then your receiver comes back on, so the anti-Vox, you have to turn your anti-Vox down where it won't come on due to outside noises or extraneous noises. And sometimes you can tune your wife and dog out, and sometimes you can't. But that's what it's for. It's to keep it from turning on, except when you intend it to. Okay, any questions on that?
Nope.
Key jack. The key jack is the hole in the transmitter where you can plug a microphone or a key in. A key jack is for a key. And most keys have a cord that will fit your key jack. Now, remember I said that when I was using the headset, that headset didn't have any PTT button on there, push to talk. So I had to find a way to key it. So if I'm using a hand keyer or a foot pedal type keyer, I would plug that into my key jack, my Morse code jack, my key jack. And when I step on that pedal, it would open the transmitter. And so they could hear me. When I release the pedal, it would see. Bypassing, push to talk, and built in to like a handheld receiver or a desk mic. Okay. Now, some receivers, not all of them. In fact, I've seen very few of them, but some of them do have a MOX on them or a send. And that's a button on the front, usually somewhere in the upper, that you push in, and it turns the transceiver on transmit and stays on transmit until you push the button. So again, so you need to be careful of that one. But that's one way. If you don't have, that's one way of keying the transmitter, is by pushing the box and then pushing it again, push it twice. It usually locks on and then push it and it'll lock on. Okay, Morse code keys are straight keys. You know, I think everybody's seen this. Does anybody not know what a straight key is? You know, it's basically a switch. It's on and off. Electronic keyer and paddle are a semi-automatic bug. And I looked for mine and I didn't think about them until just before, and I didn't find the bug. Oh, I have some keys around here. But this is what's called paddle. And the big black box that's on there is a sounder. And on one paddle makes DAWs, and the others make dashes. Can you hear that? Can you hear that? No? Yeah. I think that's as loud as I can go. Let me see. You can't hear that?
Nope.
Well, I'm sorry. Take my word for it, you know. But you use both, you use your thumb and your forefinger like that.
So one for DAWs, one for DITs.
Okay.
One for DAWs, one for DITs.
That's right. And you can squeeze them together and go da 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 da, which coincidentally is a period, you know, da 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 da. Or you could go da dit, depending on which one you squeeze from. So it will act either way. There's loud enough for me to hear. Okay. I don't have handy. I can't think of it. We'll have a straight key to show you, but you know what a straight key is. A typical telegraph key.
Yeah.
And a bug is like like the paddle, only instead of being electronic, it's mechanical. And it has a big backside to it. And when you push it over, when you push it one way for dots and one way for dashes, but when you push it to dots, it has a spring on the end that vibrates and makes and breaks contact. So I can push it to one side and it'll go dot, 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 dot. The dash you have to make on your own. It's just like a straight key dash. Dot, 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 dot. You know. Anyway, that's how a bug works. And if you want more information on that, let Mark know and I'll find my keys.
Do very many
Okay.
people use the Morse code anymore?
Yeah. Morse code is not required anymore.
Yeah.
But since it's not required, it's become a challenge for a lot of people. And there are a lot of people who Morse code ends of the band, basically on the low frequency end of all the band.
Right.
You can always find Morse code on.
Okay.
Generally, though, they happen to run at 35 words a minute. The guys who really know it well and run it real fast. There you can find slower code on there, and of course the convention is, or the rule of thumb is, you always enter a code at the same speed he sends it. So if you send a slow call sign, then supposedly the guy will hear that and he will send back slowly. So you hope that happens.
Yeah.
But in a contest and stuff like that, most bets are all, But anyways, it's fascinating to listen to. All right, receiver controls and function. Receiver, AF gain, or volume, they say. That's what it is. It's a volume control. It's the audio frequency gain. Controls the audio level of the speakers or headphones. And you turn that up just like you would a volume control. Then there's an RF gain. And it controls the gain of the receiver's amplifier, the input amplifier. Now, for a lot of years, I cranked my gain all the way to max and left it there because there wasn't anything that was too loud to listen to for me. I could always turn down with the volume. But since then, I have learned in the years of operating that you can get a lot of signal that are loud but still have some noise behind them, and that noise will wear you out. So what you can do is a lot of times you can creep and barely turn that RF receiver down until you can get it to where the noise goes away, but the person talking is just fine. And that makes it a lot more pleasant to listen to. And a lot of times you can dig people, when they're right down near the noise level, it's hard to understand them. But sometimes you can use that to dig them out of the mud, as they call it. Then there are attenuators, and they reduce the signal at the receiver's input. I've never used one. I'm always looking for more signal and not less. But if you lived in New York City and you had a bunch of people packed in together, and the guy was using a kilowatt or something like that, or 1,500 amps, and he's just next door, you might want to use an antenna, an attenuator, to block him out of your receiver. You might be able to knock him down. Okay. Receiver controls and function. Incremental tuning, or RIT. You don't need it, I don't think, as much anymore, but we used to have the net, and you know what a net is. A net is where a lot of people get together and talk, and there's a net control that controls the net. But we had a gossip type net. This was a long time ago, and then we had also on some of the other nets, we had a guy who had a Swan transmitter, and a Swan is an old boat anchor transmitter, and they are notorious for drifting out of tune. So when you would listen to him, he would start drifting, and when you're on sideband and start drifting, your voice begins to sound either like Mickey Mouse or Donald Duck, you know, depending on whether you're drifting to the low band or drifting to the high end of the band. So instead of taking the big tuning knob, which is tuned into the frequency that the net is set for, you can use that incremental tuning and tune him in so he sounds good. And then go back when other people are on and never have to move your, so you can transmit, talk to him on a frequency. He may be listening, it may be drifting bad enough that he's listening in a different place than he's transmitting. So anyway, you can make up for a difference in transmit and receive that way. And adjust the, it's fine tuning, adjust the receiver independent of the main VFO. So you're not getting off frequency when you do it. And it doesn't vary the transmitted frequency. So when you're talking on the frequency that's set on your VFO and that you'd read on your display. A lot of transmitters, not all of them, but a lot of them have similar functions called an HI, which is a transmit incremental. And I've never had to use that. Most transmitters are such that I'll tell you where you would use them the most probably is if you were doing CW and you know you're at the signal, you've tuned into the signal, but you may like to hear the beep, you know, the beep that the Morse code is giving you, either a little higher or a little lower to set your ears. So you can use the RIT or the XIT to adjust that. And you'd probably use it more in those situations than you would.
Bill?
Yes.
I was going to say on my Kenwood HF rig, I on 10 meters when I'm doing the net, I have to use the RIT on mine because for some reason that's the only place in the whole frequency world that it's off, and it's 11 megacycles. So I have to set it at 011 RIT and negative in order to be clear.
Okay. Okay. Well, there's another reason for it. Anyway, it doesn't change your VHO, but you can retune the receiver or the transmitter so you'd sound better. Okay, receiver controls and functions, automatic gain control. Okay, it automatic limits the incoming signals. Just a second, I'm gonna have to scoot you guys. During voice peaks, maintain an even volume. Okay, yeah, that's what the limit, the automatic limiting control does for transceivers, the automatic gain control does for receivers. So it keeps strong signals from blasting the listener. It's what you had on your TV when some of the commercials come on. You know, they're usually louder in volume than the program. And automatic gain control would reduce that down to the same level. Okay, different time response settings. This is for your automatic gain control. You would set it fast for CW because CW it doesn't take long, you know, just dit, dot, dit, dot. So it has to respond very fast. Slow settings for your voice. So you don't want it jumping all around and changing when you're, at mid syllable. You don't want it cutting you off. And AM, SSB and AM. And you don't use an FM because the amplitude there is always constant. You're changing the frequency, remember, not the amplitude. Okay, has everybody got those down? Fast for CW, fast for very short bursts, slow for voice, and not used in FM. Squelch. Squelch is used a lot on VHF, particularly the handy talkies. And what squelch does, put that. Okay. When I'm parrot, I'm going to go to my parrot again on my DMR, AE5F testing. Okay. Now, with the squelch, if I didn't have squelch on this, it would sound like this. Whoops. Well. AE5F testing. Well, I'm not getting a monitor on that. Maybe it has to be. You know, why do demonstrations always work before you get in front of a class? Okay,
Murphy has something to do with that.
you hear that? Hear that noise? Can you hear that? That's what the squelch. That's what the squelch completely off. And what you might do when you turn your squelch up to eliminate that noise. And on an FM receiver, you would turn your squelch until the background noise goes away. And then signals that are higher than the squelch, you can hear. And primarily, you might want to open the squelch when you think there's a weak signal coming to you, and you wouldn't be able to hear it with the squelch on because the squelch would think it was noise and squelch it out. So if you turn the monitor on, you hear the noise. Turn the squelch on, you hear the noise. But any signal that is flow with that noise can also come through. And the response says it mutes the audio signal when there's nothing when there's no communication present, and you open it with and most radios have a monitor button that you can press to open the squelch without adjusting the squelch control. So as soon as you release the monitor button, it goes back to release. Also, if you're getting some type of interference or some noise that is very weak, you can usually squelch it out and talk over it by using the squelch button. Any questions?
It's just
Advanced squelch and control until the noise disappears. That's just what I said. And you open the squelch of the monitor, and that's what I did. The reason I really can't show you the squelch on these radios, all the radios I have here, is because the squelch is digital. And I have to go in the menu and change the squelch digitally, which is no fun. I don't think they work as well either, but that's what you're stuck with. Okay, more receiver controls and function. Filters. Okay, we could talk a long time about filters, but fortunately I won't. A filter can be an electronic module, which is a mechanical filter you put in your machine or in between the feed line or something like that, or a DSP, which is a digital signal processor. IF is IF means the intermediate frequency filter. It's used to narrow the width of a signal that is passed and attenuate adjacent signals. Okay. So filter, the newer radios, the SDR type radios, you can do a lot with filtration that you can't do with mechanical filter. You can vary the sharpness and the shoulders and the skirts of the filters. You can move them. You can make them very narrow or very wide. You can do a lot. Okay, and but it's going to depend on the radio you have, what you can do with it. The notch filter is a very narrow filter that can be removed over an interfering filter. The most things we use notch for is when people tune up, they have to put an audio sound out to tune. And they transmit a 10-watt sound or something, and they tune according to that sound. Now, if you're on the receiving end, when you're trying to talk, when you're trying to, you hear this a lot in pilot, somebody's trying to pilot, and all of a sudden you hear this beep that's going through the pilot and it messes you up. That's somebody trying to tune in there. But a notch filter will move over that and take that out, and you can hear the people talking around it. Notch filters are pretty useful. Removes pulses, and it's more for your automobiles when you have engine noise or some kind of noise like that, spark noise maybe. It can remove that. You can help take that off. It's associated with randomly generated noise. Okay, noise reduction. PS or DSP again. The function to remove noise from a signal. Okay, we talked about the DSP before. A noise limiter. It simply limits the maximum volume of a noise pulse. It doesn't try to get rid of it, it just knocks it down. The preamplifier usually amplifies what's coming in from the antenna before it gets to the amplifiers in the receiver. And It increases sensitivity, but can increase overload. The main, and most transceivers have preamps in them. I don't use them very much because usually I can't hear somebody because of noise, and a preamp will amplify the noise just as much as it does the signal. So if you have some noise, they're kind of worthless, in my opinion. Reception and transmit meters. Okay, you have meters on your receivers that tell you how the ALC is doing. It tells you when you're in the receive, it says S units 1 through 9, with S9 is the strongest S number, but above 9, they'll rate it in decibels, such as S9 plus 10 dB. When you're giving somebody a signal report, you would say your S9 or your S7, depending on what it is on your antenna. Now, the S level is, if you don't have a very good antenna, your receive signals will be weaker, and it'll be S5, S4, S3 maybe. If you have a good antenna, they'll be up in the 9s and all. And if you have a good antenna and the guy is nice and strong, you'll be 9 plus 10 dB or 20 dB. Any questions about that? About the meters, okay? The receiver can be limited to the ham bands or other parts of the spectrum, usually with transceivers. You can listen all over the ham, and you can listen all over the band. You can dial in your AM broadcast or your FM broadcast, or you can dial in WW1 and set your watch just to the right second and everything. Those are called general coverage, and they also can be used for shortwave listening. Okay, data modes. There are data modes, which we just call data. They're computer to computer communication, specialized, that used to use specialized modems called TNCs, which stands for terminal node controller, or an MPC, a multiple protocol controller. And your computer requires a sound card, which is, you can tell that this is dated, but a lot of the terminal node controllers, or TNCs, would have the sound card built in them, and they would hook to your transceiver or to your receiver and transceiver, and go provide the sound card, and would transmit the sounds appropriate for the information you were using, or the data you were using. Popular digital modes and system. Radio teletype, or RIDI, that's used a lot now on DXing. PSK 31, that was one of the first real popular of the modern digital modes. MSK, that's multiple frequency shift key. That is a mode. Packet radio and PAC4. It used to be very popular. It's not used much anymore. CW is used a lot. And I think Morse code, you know what that is. The automatic reporting system, that was very popular years ago. And what it was the GPS that you would broadcast out. You could track somebody on a map who was APS, automatic reporting system. And they could tell what road you were on, they could tell how fast you were going and such as that. And also you could do messages between each other. Pardon me. Okay, FD8 is one of the newer means of communication. It's a very weak signal, and there's a Thomas, is that the kid? John Thomas, is that the guy? I forget his name right now. But he's created all these. They're very weak signal for very few watts. You can probably go around the world. And then the WinLink system is basically it's computer terminal to computer terminal. So it's PSK31, but WinLink has the I for emergency communications. And it's basically will send emails for one governmental unit to send emails to another governmental unit, or a ham supporting them to send the emails back and forth so that they can work. It's when you need a paper copy, when you're sending a lot of information. Okay, digital modes and systems, error detections. Yes, like a radio and MSSK does have error correction. And no for RIDI and PSK31. And then the error correction, MSK is forward error correction, or FEC. And packet radio is checksums and call sign. And retransmission are QRO. On the checksums and the retransmission, it would send a packet out, a packet of data, and say it would check some and said you had 9 digits in there. It would count them. If it had 9 digits, it would say it was good. If it had 6 digits, it would QRO, and you'd send it again and send it again until I got all 9. Anyway, that's how that works. This is how you set up a digital station, a terminal node controller. Most newer radios have the digital functions built in, and you can use them. You won't need a terminal node controller, and they will hook up pretty much the same. Okay. Everybody got that? Any questions? Internet gateway. Okay, this is basically how it works. I was using an internet gateway when I was using the parent function on this radio, this DMR radio, because it's data and it's digital. And I was calling a repeater that was the gateway that it would translate this digital signal, put it on the internet, and then take it to wherever I chose for it to go, and then come out another repeater and change it to analog, to VHS or UHS, or maybe back to digital. So somebody with a digital radio can hear me over there. So essentially, you can use this radio that I'm holding in my hand and virtually talk all over the world, all around the world, because you're using the internet. Okay, this is one of the maps for the APRS. This is automatic position reporting. I've heard it called other things, automatic something reporting. What they call it, I forget now. But anyway, you can use that. That's one of the maps that would call up on your computer, and you would follow somebody. There'd be a little check mark. Well, there might be a little house with a flag on it that would give a call sign and say where it was. Okay, now we'll talk power supplies. None of the radios except the handy talkies have their own power supplies. And you have to have something to convert the AC voltage in your house, the 120 volts, into a DC 13.8 volt. And you do it with a or some other. Power supplies is that they generally will put out the power. Most power supplies will not, like lab power supplies and other power supplies, don't put out enough voltage to be any use in ham radio. So there's a different power supply. It's very light. It's very small. It has 2 meters on it. One that will tell you the amperes or the current, and one that will tell you the volts. And on this one, it has the ability to adjust your volts, although there's a D10 at 13.8, but you can adjust it for more volts or less volts. Also, it has 5-way binding posts in front, or like your car, it has a cigarette or a port where you can draw electricity from. So you can run your transceiver, your handy talkie, or your mobile rig off that if you had it wired up with a cigarette lighter. This happens to be a switching power supply. New in the radio business, a switching power supply is a power supply that uses it's the same kind of power supply like your computer uses. Computers use switching power supply. They don't have big heavy transformers. Others about where that microphone row is a 30 amp Anderson linear, what they call a linear power supply, and it's a heavy type. It's heavy. You'd never use that on a to go. It's just too heavy, but it's reliable, it's accurate, and it runs forever. Let me see, AC power. Okay, all the power supplies are very regulated and filtered, and they give you a smooth 13.8 volts. What I'm trying to say, pretty flat. If you look at it on an oscilloscope, it's a pretty flat line. Now, the bad rap on switching power supplies is when they first came into to operation, because they are switching, because of the way they operate, they have a tone as their switching frequency, which would sometimes interfere with would be the same frequency as a band you were trying to operate on. And it would knock that little piece of the band out. And there wasn't anything you could do about it. And then eventually they got to where they made power supplies with a little knob on them so you could move that switching off. If you happen to be wanting to operate right where they switch, you can move that tone away to the side so you can operate there. And then now the switching power supplies really don't have any tones in them. If you get a modern one, they work well. Okay, linear, they use an iron transformer. They're heavier. They do not emit and are generally not RF, and are generally not used as strong switching or a strong signal. Switching transformers are electronic instead of transformers. Switching electronics instead of transformers. They're lightweight and small, but they can emit RF if not properly filtered. So your check of product reviews is one of the best ways of doing it. I'm not having any problem with MFJ transformer, or I have any problem with Aston type linear power supplies. Okay, ratings and voltage, and what does that say? I can't read this thing. Current, okay. Power supplies are rated. They're generally rated for their, not the continuous duty, but for their intermittent duty, because that's a higher rating. So that's the one they usually advertise. But a continuous duty says how much will it supply continuously. And if you're using something like RIDI or CW, you're in transmit mode for a long time. And a power supply that has a intermediate duty that will not take the power that you're using will get hot and can damage itself. So continuous duty is usually a lot lower. By a lot, I mean not 10 amps, but a few amps lower than intermittent duty. And regulation is how well the power supply maintains a constant voltage amplitude. As you can imagine, this voltage surge is tremendous between receive, which takes very few volts, and transmit, which will take a lot of volts. Okay, or a lot of power. Not, more powering wiring, more mobile power wiring safety. Car batteries, be careful. You short them out. How many people have melted a screwdriver trying to work on their car battery? It can do it. If you arc between the two terminals, there's enough power left in that battery, it will melt the screwdriver. Special safety requirements for safe car wiring. Fuse both the negative
Fuse both sides.
here on this wire lead, both the red and the black are fused. And this is what would go to the terminal. Both the red one and the black one. And mostly people who know something about electronics said, well, you'd only need to fuse, the power one, the one that's the power's going through. And the power's coming back from the red one. The negative one, the little electrons are going from the negative around to the and or vice versa. I forget which it is. But point being is, if something should happen somewhere along the line, something else happened, it could be that your radio connected to the power could be the only thing drawing power through it, and say the thing that shorted out or went down was, 50 amps or 100 amps, then you'd have 100 amps going through you. That was a starter motor. It was flowing through your transmitter and your transceiver, and you'd lose it. You'd just smoke it. So you fuse both the negative and positive leads, as it can go. They can blow from both directions. If you go through a firewall or go through sheets of metal, be sure to use grommets or something to protect the wires, because as the car goes down the road and vibrates, it'll feed through the insulation. And particularly nowadays, don't assume that all metal in the car is grounded. There's modern cars are as much plastic as metal. An antenna has to be grounded. So you may have to get a ground strap and ground your trunk if you have a trunk lid mounted. You may trunk lip mounting device to mount your antenna on the trunk lid. You may have to ground the trunk through the rest of the body of the car, because it may not be grounded if you don't watch it. Don't assume that all metal in the car is grounded. Yeah. Batteries. Okay, they create current through chemical reaction. Individual cells are connected in series or parallel. Cell chemistry determines voltage per cell. Alkaline batteries are 1.5 volts. Lithium batteries are metal NiCad and metal halide batteries around 1.2 volts. And then lithium ion batteries are about 3.7 volts. So a battery in the battery, it depends on what kind of cells they have. Your car battery is about 2 volts. That's why there's six cells in a 12-volt battery, why there's 6 places to add fluid to it. Okay, disposable batteries like your alkalines are primary batteries. Use them and you throw them away. Rechargeable or secondary batteries. Your nickel metal halides, your lithium ions, your lead acid batteries, your storage batteries, your deep cycle batteries. All those are rechargeable and not disposable until the end of their life cycle. Okay. And it's just because you get a battery that says it's good for 7 amp hours, don't believe you can run 7 amps for 1 hour. There's a lot of caveats to that, but it's a good way of telling how capable one battery is versus electricity is stored, how much it can give you. But a lot of it has, the amp hours are usually rated at a much lower voltage than you would probably use them. So you probably won't get the amp hours out of them. That's stated. Anyway, and if you're transmitting and talking and listening, seeing and listening, then you have, your duty cycle. That's called a duty cycle. How much you talk versus how much you listen. You talk a lot less than you listen normally, or you're trying to find somebody, tuning around and everything. So the receiver works constantly, the transmitter works intermittently. So anyway, amp hours is a way to judge whether a battery is good or not. Be careful of Chinese batteries; they're not rated the same. If you get a few alkaline batteries So you get some energizers and you get some Chinese AA batteries and energizer AA's and look at them. They may look alike, they may be the same size, they may be rated the same, but they usually won't last as long. The Chinese won't last long. If you put them on a scale, you can see that the Chinese batteries will usually weigh a lot less than the Energizer batteries. I'm not saying all Chinese batteries are bad. I'm just saying there are a lot of bad ones on the internet. Battery charging. Don't try to charge disposable batteries. Okay, some batteries can be use a proper charger for the battery charge. It's getting more difficult because we have different types of batteries. Yeah, and you know how critical charging is because you know what problem Samsung had with blowing up batteries in people's pockets when they were trying to charge them or when they were using them and discharging them. It says the charging in the batteries weren't good, and there's a lot of energy, and I'm sure there are videos on the internet. You can see those Samsung phone batteries go off. They really you don't want to. So use the top charger and follow the directions. Battery will lose capacity with each cycle. That means every time it won't charge up quite as much as it did the time before. Charge up, but some batteries are more consistent and then they go down. So you have to see the type and this type of chemistry and type of anode and cathode that the manufacturer uses. You can find charts on all of that. Tested batteries are maintained fully charged, but overcharging will cause heating and could damage the batteries. Some battery chargers, a lot of battery chargers now, have a thermistor in them that will measure the temperature of the battery and won't let the battery get too hot when it charges. And that's very important because when it gets too hot, you drive all the moisture out of the battery, or you could cause it to explode. Acid batteries release explosive hydrogen during charging, rapid discharging. So ventilation is required. It's real important if you've been charging a lead acid battery, and if you unplug the charger before you remove it from the battery, so there's no chance of a spark there, which in few, but some devastating cases, there have been instances of the hydrogen hanging around a battery, and when you take those clips off, you might spark a little bit, and they might blow up. Automobiles can be a good emergency source for recharging a battery. Your hand batteries or any battery that you're using, like I say, it works on 12-volt batteries, so or 13-point volts. So generally, if you're running your car and charging it on there, you'll get voltage and you'll recharge your batteries. 12-volt lead acid station batteries can be recharged by connecting automobile electrical system. Just what I said. Okay, monitor the battery temperature, make sure it's not getting too hot, and make sure it's well ventilated. Battery packs, they're nickel cadmium, nickel metal hydride, and lithium ion. We talked about all that. For emergency, has a battery pack that can use disposable AA's. We talked about that. And goodness gracious, we got to the end. Do I have anybody left? Probably not. Well, watch it on YouTube.
We'll see here.
That's all I have to say unless there are any questions.
Bill, thank you.
Go overtime.
No, you're fine.
Okay.
Hey, Bill, thank you so much. I don't know if you
Oh,
remember, me,
okay.
but we used to enjoy a lot of hot dogs at the Lions Club fairs.
Yeah. Yeah.
BJ.